Welcome to Power My Edu. Today we will be looking at few solved examples on trigonometric ratios and identities. These are very basic and simple problems, but still it will make you understand on how to approach similar problems. I have taken these examples from the very famous IIT Mathematics book by Khanna and J.N. Sharma. So let's have a look on the first question. For each natural number k, let Ck denote the circle with radius k centimeters and center at origin. On the circle Ck, a particle moves k centimeters in anti-clockwise direction. After completing its motion on Ck, the particle moves to Ck plus 1 in the radial direction. The motion of the particle continues in this fashion. The particle starts at 1 0, the coordinate 1 0. If the particle crosses the positive direction on x-axis for the first time on circle Cn, then find n. So what is happening is a lot of circles C1, C2, C3, and a particle is moving on the circle and it's changing its circle, say from C1 to C2 and C2 to C3 and so on. And on each circle it moves a distance equal to the radius of the circle. So after moving k centimeter on Ck, it will move k plus 1 centimeter on Ck plus 1 and so on. And at a particular time, because it's moving like this in an anti-clockwise direction in different circles, it will cross x-axis for the first time in positive direction like this, and we need to find the circle on which it will cross the x-axis for the first time. Okay, so as all these circles have their center at origin, they are concentric circles. Let's try to figure out the motion of the particles on these circles. Let's have these circles C1, C2, C3 and so on. Let's have the origin, say O, and we'll have a x-axis. Now our particle is on 1 0, which is on x-axis. Let's call it A1. Now the particle starts its motion. It will go in anti-clockwise direction for k centimeters, that is 1 centimeter, in anti-clockwise direction like this, and say reach B1. Now after reaching B1, it will move to Ck plus 1, that is C2, in a radial direction. So it will move like this to reach, say, A2. From A2 again it will start its motion in anti-clockwise direction for 2 centimeters this time on C2 and reach, say, B2. And again it will move to C3 in a radial direction like this. And then again it will like of a circle with radius r at center is L by r radius. What happens is, as this particle is moving on circle, if we can find out the radian is traveling on each circle, then we can find out after how much radian across the circle, and we find out the angle subtended by A1 B1 divided by A2 V2. Again similarly it will be A2 V2 length, that is 2 divided by length of the radius of C2, that is 2 centimeters, that is 1 radians. So total becomes 1 plus 1, 2 radians after completing its motion on C2. So similarly, as the particle continues in the similar fashion, after C3 completing motion on C3, it will be 3 radians and so on. Now we need to find out where is the particle when it completes 2 pi radians, because it starts from the x-axis, goes into anti-clockwise direction, and again like this crosses x-axis from the positive direction for the first time. So it will be 2 pi radians. When is it describing 2 pi radians? So to cross 2 pi radians, that is 2 multiplied by 22 by 7, that is 6.7 radians. Now it's very simple to guess. After C1 it's 1 radian, C2 it's 2 radians, C3 it's 3 radians. So on C7 it will cross 7 radians, and on C6 it would have crossed 6 radians. So it will cross the x-axis when it is on C7. Hence n is equal to 7. We got the answer. Now this solution was very simple, because over here our particle was moving in a very simple fashion, like this and then like this and like this, just in a singular anti-clockwise direction all the time. But we may have a bit twisted questions or little tricky question where there is a particle, say, which is moving first clockwise and then anti-clockwise and then clockwise bigger and then anti-clockwise and so on. You need to remember that to understand the motion of the particle, so that once we understand the pattern in its motion, we can trace rotation anytime in that pattern at least, and then we can easily tell where it is after, say, making so many radians, when it will cross x-axis or y-axis from positive direction, negative direction, or after traveling so many radians, what is its coordinate and so on. Those can be find out. The trick is to understand the motion, how it is moving, just slowly seeing in this way, drawing it out if needed, and then finding the pattern and solving it out.